Okay, good morning everyone. So I wanted to make a video for this lesson, and now you're just going to follow through. And again, when I do the videos, I kind of teach you a topic and then I do some with you, and then you're going to do some apart. And I need the whole packet by the end of class. You'll notice here is your homework 4. It's also at the top of your packet right now. All right, so the warm-up are just some questions to get you kind of thinking about what this topic is going to be about. It is called quotients with radicals. Quotients mean division, so there's going to be some dividing of it. So here's our warm-up. You really don't even need a calculator for a lot of these because a lot of them kind of simplify nicely. So here's the trick for these. Remember how from last class when underneath the radical, if they're the same number out here and they're both 2 because there's no number, it's just the square root of 49. Well, what's the square root of 49? It's back to 7. Let's try another one that looks similar to that. This one. We have the square root of 4x squared. Well, let's see. The square root of 4 is 2. And if I do 2 divided by 2, guess what I get? X. So notice, and this is true for every single one of these problems, if I multiply radicals with the same terms underneath, my answer is just that whatever was under there. So this one I had 2x under the radical times 2x also under the radical, so my final answer is just 2x. Again, works every time, no matter what is under there. Going to be important to remember today. It'll save you some time. The next one. The next one is really nothing tricky. You can't do anything with that 12, or you can do something with that 12, just kidding. You can kind of remove it like what we did last class where some people were a little struggling. It's the square root of 4 times the square root of 3 times the square root of y. I still have the 40 hanging out. Nothing to touch. I'm not touching the 40. What is my square root of 4 though? It's 2. So I'm actually going to go over here. I didn't save enough room here. We have 40 times 2 times the square root of 3 times the square root of y. And now just combining it, we have 80 square root of 3y. Just to kind of take that, simplify this. This is the only part that we really can simplify. Is right here. Everything else is kind of staying the way it is. All right, next one. Next one is simple division. Nothing tricky here. I always like to focus on the numbers first. So we have 48 divided by 4. What is that? That is 12. 12 is kind of our main number, as we might say. It's our whole number, so it's going to go in the numerator. Now that w is still in the denominator, so it has to stay in the denominator. So that's why this answer is just 12 over w. You could put 12 over 1w, if that kind of makes you see it easier, because 48 divided by 4 is 12 over 1. But either way, it's good. Next one. Simply distributing. Okay? First one should be easy. Negative 2 times 5 is simply negative 10. Now when you are multiplying, I guess a number times a number that has also a radical, all you do is you multiply this and this. Square root stays exactly the same. So it's going to be minus 6 times square root of 7. Again, the radical doesn't change because nothing else is underneath the radical. If something else was underneath the radical, that's going to be like our next one here. We're multiplying two things that are underneath the radical. Well, 4 is just going to still hang out. And then what's 3 times 27? It's 81. Well, what is the square root of 81? 9. So 4 times 9 is 36. So there's our answer for that one. Again, a lot of little tricks that we've covered already, but you just need to remember for this topic. All right, so we're flipping to the next page. Here is the objective. Oops. Students will learn how to rationalize the denominator in order to rewrite or simplify expressions with radicals. Rationalizing the denominator, such a huge topic. I was talking to trig teachers and HCC teachers, and they all say that this is something that people forget to do, but it's very important. Rationalizing the denominator just means I just want a regular, I'm going to put that in quote, a regular number underneath. So you're going to have problems that are going to have a radical under here, but you can't have that. It's not really a legal math. So we're going to change it so it just has something normal underneath, okay? That's all we're doing. So if you could write the objective in the box there. And then we're going to actually give you a formal definition of rationalizing the denominator. Well, hold on, I guess before that, we're on day 5. So remember, next week we're going to do day 6, and then your test, if you're in a B day class, is on Wednesday, and if you're in an A day class, it's on Thursday. Okay? I'll have it written on the board as well. All right, so here is your definition. Rationalizing the denominator, and inside that box, it is the process of writing a fraction in an equivalent form without irrational numbers, meaning our radical sign. Okay? That's what we're doing. So take a second to write that. Okay, so we're into the first part. I can't remember how many parts there are, but there's a couple of parts. So here's the first part again. I just wanted to refresh our memory from the warm-up here. And you should be able to solve this like this, or like that, very quickly anyway. Square root of 5 times square root of 5. You can either solve it the long way, where it's square root of 25, and then we know it's 5, or there's 5's under there, so I know my answer is going to be 5. Same thing with this one. I know my answer is already going to be 805. They're the same number underneath there. So my answer is just 805 regular. No radical, no square, no nothing. Okay? And there you go. You could type it in the calculator, but remember, this will not be a calculator problem. Okay? This is something that you're supposed to know in your head. Which again, it's not really that difficult. Alright, so here's some examples that you'll see on your test. I'm going to do 4, and then I think I have you maybe doing some too. Okay. Here's how you rationalize the denominator, and we have done this before. We did it with imaginary numbers. So now we're going to do it with radicals. It is the same idea though. You need to multiply, so I'm going to put a multiplication sign and then a fraction. You need to multiply whatever is in the denominator, and you need to multiply that as a fraction. So I'm going to multiply this by square root of 2 in the numerator and square root of 2 in the denominator. That's because this is the square root of 2. This is a legal move, because think about it. If I have the square root of 2 divided by the square root of 2, guess what that equals? That equals 1. So I'm really just multiplying by 1. But again, it's a little bit of different numbers, so I'm kind of tricking the numbers into thinking I'm doing something that I'm not. Okay, now we just solve from there. 3 times the square root of 2, really a no-brainer. It's just 3 square root of 2. And we just focused almost 4 or 5 times already. Square root of 2 times square root of 2 is just 2. There's my final answer. Again, I like it better because I don't have a radical in the denominator anymore. Next one, number 2 over here. Square root of 10. So I'm going to multiply square root of 10, top and bottom. Numerator, nothing weird there. 30 square root of 10. And then my denominator just becomes 10. Now we're not quite done this one because I can simplify it. Look at the regular numbers. If I'm not looking at this part right here, I'm crossing that off with my hand here. What's 30 divided by 10? 3, right? So it's just 3 square root of 10. There's my answer. All right, number 4. So I have a little bit different. Notice here in 1 and 2, I only had a rational number in my numerator. Now I have an irrational part. Same idea though. Again, what I'm going to multiply by on each side, square root of 2, square root of 2. Numerator got to do a little bit more work now. 18, there's no other number outside the radical, so it's just going to be 18. But now since 18 and 2 are both underneath that radical, I can multiply them. Well, 18 times 2 is 36. Square root of 2 times square root of 2, we should know right away, just 2. Now here's where hopefully you're kind of thinking about it, light bulbs are going off a little. What is the square root of 36? 6, yeah. So it's over 2. So now you just kind of solve. Again, it's really just simplifying. I'm not really trying to trick you, I swear. 18 times 6 is 108 over 2. So my final answer is 54. Look how nice that becomes. Let's try the same thing with number 4. Times square root of 3, 3. Numerator, a little bit more work now, 2. And then 27 times 3 is 81, all over 3. Square root of 81 is actually a number, which sometimes it will happen. 2 times 9 now, over 3. So I have 18 over 3, which is simply 6. Well, now if you flip the page over, I have 6 of those problems for you to try yourself. Please write out your work. Since I'm not here, or I might not be here for your class, I need to see your work to make sure you're getting it. So please show your work if you would like full points. All right, here's the second type of problem. Again, now we're actually going to introduce variables. We didn't have any variables before. We just had regular kind of numbers. Now we're going to have variables. But the same idea of our remember part. Square root of x times square root of x. Well, the square roots kind of cancel, and I'm just left with x. Over here, same idea. Square root of 8y, square root of 8y. I could solve it out the hard way, 64y squared, but it's really just equaling 8y. I have 4 examples I'm going to do with you on this one, and then you're going to keep on practicing. Okay, so here's my 4 examples. Again, it's the same idea. Whatever is in the denominator, you are going to multiply by. So we have the square root of 7a. So 7a of the square root of 7a in the numerator, square root of 7a in the denominator. Well, the first one, not too tricky. We have 1 times the square root of a. We could write 1 square root of 7a, or you could just write 7a. And the denominator, remember, radicals cancel, it's just 7a. And that's it. 1 over, just kidding. Hold up. Square root of 7a over 7a. There you go. All right, next one. I need to multiply by the square root of a. So my numerator becomes 5a square root of a, and then my denominator becomes a. I can simplify this one even more. If I have an a in the numerator and an a in the denominator, they actually go away. So my final answer is just 5 square root of a. All right, let's do these next ones. Okay, 32 over 8, or the square root of 8w. Multiply by 8w on both sides. My numerator becomes 32 square root of 8w. My denominator becomes just 8w. Now I can't do anything with that radical. There's no more radicals. But look at this, 32 over 8w. It's like our warm-up problem that I was talking about. We can simplify that. 32 divided by 8 is 4. And then I still have the square root of 8w in the numerator. Then I still have that regular w in the denominator. So then there's my answer. I can't take the square root of 8. I don't know what the square root of 8 is. All right, my last one that I'll do with you. 27 over the square root of 3x. Multiply by 3x, or the square root of 3x on both sides. 27 square root of 3x, all over 3x. Again, same sort of idea. Nothing's going to happen with the radical. I would just like to draw a fraction. I know that square root of 3x is still going to stay in the numerator. 27 over 3, well, that's 9. But then I still have that x hanging out in the denominator. So try those next 6. Again, show your work again, receive full points, and need to look at it. Okay, here are some rules and refresh our memory sort of deal. Here's the rules first. It's at the bottom of this page. What I want us to do is the opposite rule. So we actually focused on this when you're multiplying things. You multiply by the opposite, meaning you change the sign. So nothing really strenuous here. If it was 3 plus 9 square root of 5, I'm just changing it to 3 minus 9 square root of 5. I'm not changing the order. I'm not changing anything else. I'm just changing that addition sign to a subtraction sign. Same thing with this one. If it's 7 minus 4 square root of 8, it's becoming 7 plus 4 square root of 8. All right, now our refresh. If you look on the next page. This is going to be the longer type of problems. I'm not going to lie there. There's a little bit more work involved with these because of this right here. Think about it. When you have two binomials being multiplied, you have to FOIL. So I'm going to see if you can see the kind of almost the trick. 2 times 2, oops, there's not 2, is 4. 2 times negative square root of 6 is minus square root of 6. Right here we have plus 2 square root of 6. And my last one is square root of 6 times negative square root of 6. Now you should know what that means already. We've done them. I'm just going to do a little sidebar here on this last one. Square root of 6 times negative square root of 6. We did these all in our warm-up and our first problem. They're the same number underneath there. So guess what? It's going to be the same number. You just have to add on that negative. So that's what I'm going to do. So it's just minus 6. It'll save you so much time if you can remember that. Or if you can't, if you like to see it worked out, I'll do it over here. I'll erase this. Square root of 6 times negative 36 is negative square root of 36. And what's negative square root of 36? Negative 6. So again, I'm just jumping ahead just to try and save you some time. So guess what? These middle terms cross off, which is great for us because we want to get rid of radicals. So they're gone. So all it is 4 minus 6, which is just negative 2. So all of that became negative 2, which is why we're going to multiply by the opposite. Because notice, we have 2 plus square root of 6, and then this one's 2 minus square root of 6. Just like what we were thinking about up here. So when you multiply the opposite stuff together, you get a regular number, which is the overall goal. Just to refresh our memories on this one again, 7 times 7 is 49. See if you can see this one again. 7 times that is negative 14 square root of 5. Positive 14 square root of 5. And then here's where it gets a little trickier. We have those 2's in front, so it's going to be 2 times 2, which is 4. But then square root of 5 times square root of 5 is just 5. So again, a little trickier because it has that number, but nothing too major. Again, these go away. So I'm left with 49 minus, and I'll just simplify that to 20. So 49 minus 20 is 29. All right, I'm going to show you how this works in some problems. Now, these are the longest problems. Not the longest problems ever, but the longest problems of the day. So I only made 4 problems for you to try on this one yourself. So just try it out. And bear with me here. All right, the first one. 2 over 1 plus the square root of 5. Again, we need to get rid of the rational in the denominator. So I need to multiply by 1 minus square root of 5. Remember how I'm doing the opposite. 1 minus square root of 5. Okay, so now I'm going to multiply this out. My numerator, think of it as you're distributing that 2 to both terms. So we have 2 minus 2 square root of 5 in my numerator. My denominator, I'm going to write out the full work for the first two, and then I'm just going to skip that middle part for the other ones. So we have 1 times 1, which is 1. 1 times negative square root of 5, negative square root of 5, plus square root of 5. And then square root of 5 times negative square root of 5 is simply 5. So numerator, I can't change. It's just 2 minus 2 square root of 5. All over, well again, these go away. I'm left with 1 minus 5. 2 minus 2 square root of 5 over negative 4. Okay, take a second to think about it. All right, let's do number 2. Same idea. Multiply by 2 minus square root of 5. 2 minus square root of 5. Distribute that 4 to both terms. Now we can distribute it because it has that symbol in between. So 4 times 2 is 8 minus 4 square root of 5 over. I'm going to factor it fully. 2 times 2 is 4 minus 2 square root of 5 plus 2 square root of 5 minus square root of 5, or minus 5. The square root of 5 times negative square root of 5 is negative 5. Okay, so my numerator becomes the same. Can't change anything with that. On my denominator, again, these middle two terms go away. And I'm left with 4 minus 5. So we have 8 minus 4 square root of 5 over negative 1. And we can actually simplify that a little bit more. This just becomes negative 8 plus 4 square root of 5. It's kind of the opposite. What's 8 times negative 1? Negative 8. What's negative 4 times negative 1? Positive 4. All right, here comes the next two. So I'm going to multiply by the opposite. 4 minus 2 square root of 7 over 4 minus 2 square root of 7. Numerator becomes negative 20 plus 10 square root of 7 over, well, 4 times 4 is 16. I'm not even going to worry about the middle terms anymore because I know they go away. So I'm just going to do 4 times 4, and I'm going to do this one with 2 square root of 7 times negative 2 square root of 7. Which is going to be negative 4 times 7. Again, I'm skipping the middle because I know they're going to get deleted. My numerator, negative 20 plus 10 square root of 7, all over 16 minus 28. Negative 20 plus 10 square root of 7, all over 16 minus 28 is negative 12. And there you go. All right, again, a lot of work, but I want to get those good grades here. All right, next one. Last one that I'll do with you. 2 plus 4 square root of 3 over 2 plus 4 square root of 3. I get 12 plus 24 square root of 3 all over. Again, I'm just distributing that 6. 2 times 2 is 4 minus 4 times 4 is 16, and then I still have that 3. So 12 plus 24 square root of 3 over 4 minus 48. So it's 12 plus 24 square root of 3 all over negative 44. Okay, there are 4 more problems on this page, and then the whole back has 12 problems. Some are the longer ones, some are the shorter ones. I just want to see what you know. So I know where to go next class and what to review and what not to review. Okay? So try your best. You're going to turn this in at the end. So be ready to turn it in. And then don't forget about your homework. It's, what, 6 problems? 4 to 10? Not more than that. But you got it. All right? Thank you all.